Solving LPP by analytical methods. Part 1. Arbitrary trial and error method. We have seen the graphical solution to LPP. The graphical method is good enough when the number of decision variables is limited to only 2. However, in real life, there can be several decision variables to be dealt with. So the analytical methods are needed. Although simplex method is commonly used, it is essential to know about arbitrary trial and error method as well as systematic trial and error method. It is because these methods form the basis for the simplex method. So, let us consider a linear programming problem in its general form. Maximize z is equal to 4x plus 3y subject to 2x plus y less than or equal to 6 and x plus 3y is less than or equal to 8 given x and y are greater than or equal to 0. The general form can be converted to standard form by adding slack variables to the constraints and assigning 0 as the objective coefficients for the slack variable. So the standard form of the LPP will be maximize z is equal to 4x plus 3y plus 0s1 plus 0s2 subject to twice x plus y plus s1 is equal to 6. Let us say A. And x plus 3y plus s2 is equal to 8. Let us call it as B. Given x and y as well as s1 and s2 are greater than or equal to 0. Now we are getting here two simultaneous equations, but we know that these two simultaneous equations can be solved for unique solution provided they are independent and there are only two variables. However, in this particular case, there are four variables, though the equations are independent. So we can have infinite number of solutions by setting any two variables to some value. Now let us consider that when we want to solve the problem or these two simultaneous equations A and B, so we have to consider any two of these four variables to be equal to 0, or in other words, any two variables out of 4 are required to be set to 0, so that other two variables can be considered in the program and we can get solution for those variables. We can have as many as 6 cases for this particular problem. We can set x and y to 0, or s1 and y to 0, or s2 and y to 0, or s1 and x to 0, or s2 and x to 0, or s1 and s2 to 0. Now when we set x and y to 0, we get the values for s1 and s2 from these two equations A and B. s1 is 6 and s2 is 8. Substituting these values in the objective function, we get the value of z as 0. Similarly, for the second case, if we set s1 and y to 0, we get the value of x as 3 from this particular equation, and we will get the value of S2 equal to 5 from the second equation, so that the value of Z will be 12. Like that, we can get the solutions for all these 6 cases. But it is notable that for case number 3 and case number 4, we get negative values for the variables, which are not permitted in the linear programming problems, because we have put non-negativity constraint as the part of the particular problem. Therefore, these 2 cases are not feasible. Then only 4 cases are left, and if we compare the value of Z for these 4 cases, then we will conclude that in the last case, that is in the 6th case, say we are getting maximum value of Z. And the solution is x is equal to 2, y is equal to 2, S1 and S2, they are equal to 0. So, the optimal solution is given by this case 6, and it is x equal to 2, y equal to 2, and z is equal to 14. The total number of trials required in the present case are equal to combination of 4 variables taken 2 at a time, which can be worked out by 4 factorial divided by 4 minus 2, that is 2 factorial and 2 factorial, which is equal to 6. Suppose if there are 7 variables and 3 equations, then in that case the number of combinations required will be equal to 35. Therefore, the arbitrary trial and error method, though very straightforward in the concept, so is having limitations, because in case of real life problems, so we are required to consider large number of trials. The trials are arbitrary, that is illogical. Some of the trials may give us infeasible solution also. Further, when large number of trials are required to be considered, there is a chance of missing the favorable trial also. So, we can't depend upon the arbitrary trial and error method. There has to be a method, say, wherein this trial and error method will not be arbitrary, but it will be systematic. Therefore, in the next video, we will like to see systematic trial and error method. Thank you for listening.